So when you think about planetary motion, you might picture, a pretty dry physics lesson, right? But what if I told you it's actually this grand cosmic dance? Seriously, every single planet, every moon, every star, they all have their own unique moves. And in this explainer, we're going to break down the two fundamental steps that basically govern this entire celestial ballet. But before we get into the choreography, let's just start with this truly mind-bending question. What if a day lasted longer than a year? I mean, that sounds completely impossible, doesn't it? Kind of like something out of science fiction. Well, stick with me, because that's exactly what happens on a planet right here in our own solar system. Okay, so to wrap our heads around how a day can actually outlast a year, we first have to master the basics. Let's break down this cosmic dance into its two most fundamental moves. And what's so fascinating is that all the wild, really complex behavior of these planets, it all boils down to just two super simple, constant actions. Every single planet is doing these two things all the time: rotation and revolution. So let's dive into what those actually mean. All right, first up is the spin. You can think of this as the planet's own personal move, like the twirl it does all by itself on that cosmic dance floor. And the official name for this move, we call it rotation. So rotation is, quite simply, the planet spinning on its own axis. Picture a spinning top. It's just like that. And it's this continuous spin that defines how long a planet's day is. For you and me, here on Earth, this is something we experience every single, day. As our planet spins, one half gets bathed in sunlight, that's our daytime, and, of course, the other half faces away, into shadow, giving us nighttime. It's this simple, elegant cycle that creates the rhythm of our daily lives. But here's the thing, not every planet spins at the same speed, not even close. We've got our comfortable, familiar 24-hour day. But then you look at a giant like Jupiter. That thing is spinning so fast that its day is less than 10 hours long. It is the fastest spinning planet out there, a true cosmic speed dancer. Okay, so that's the spin, that's rotation. Now for the other key move, the planet's journey around the entire dance floor. This is its orbit, and we call this move revolution. So, revolution is the planet's much bigger journey, its full orbit, all the way around the sun. And while that first move, rotation, gives us a day, this grand lap around the star is what defines a planet's year. For us on Earth, that journey takes a pretty familiar 365.25 days. And hey, that little 0.25 is actually super important. It's the whole reason we have a leap year. We add an extra day every 4 years just to keep our calendar perfectly in sync with our planet's cosmic dance. And just like with rotation, the speeds of revolution are all over the place. Get this, while we complete our orbit in 1 year, far away Neptune, way out on the edge of the solar system, it takes 165 Earth years just to make a single trip around the sun. Can you imagine having a birthday party only once every 165 years? So we've got the spin, that's rotation, and we've got the orbit, that's revolution. Now, what happens when you start combining these two dance steps in different ways? Well, you get some truly wild worlds with some very, very weird days. Let's finally solve that puzzle from the beginning. Let's talk about the planet Venus. On Venus, a single day, just one full rotation, takes a mind-blowing 243 Earth days. That is one incredibly slow spin. Okay, so what about its year? How long does it take to go around the sun? Well, its revolution is actually faster than its spin. It only takes Venus about 225 Earth days to complete one full orbit. Let's put those two numbers together. A day on Venus is 243 Earth days long. A year on Venus is 225 Earth days long. Yeah, you heard that right. Its day is literally longer than its year. This is the perfect example of how combining a super slow spin with a relatively fast orbit creates a calendar that is just completely alien to us. And Venus is not the only planet with a weird schedule. Just look at this comparison. You've got Mercury, where a day is about 2/3 of its entire year. Then you have Earth with our familiar balance. And then you have the gas giants like Jupiter and Neptune with these incredibly short days but massively long years. Each planet has its own completely unique rhythm in this cosmic dance. All these extreme examples are really fascinating, but they also make you appreciate our own planet so much more. So let's bring the focus back home and talk about Earth's pretty special place in this whole dance. See, Earth's motion isn't just a bunch of numbers on a chart. It's stability, it's predictability. That's a huge reason that complex life was able to evolve and actually thrive here. Our planet's dance is remarkably steady. It really all comes down to a few Goldilocks factors that make Earth, well, just right. Our location in the solar system allows for liquid water. We have an atmosphere that protects us, and crucially for our discussion, our stable rotation creates this really moderate day-night cycle that prevents the crazy extreme temperature swings you'd see on other worlds and allows for a stable climate. You know, it really all comes back to these two simple ideas. This quote just sums it up perfectly. The Earth's rotation gives us days, the Earth's orbit of the sun gives us years. These two motions, they are truly the clockwork of our entire world. But there is one more layer to this dance. Our planet doesn't spin perfectly upright. It actually has a slight tilt to it. So I'll leave you with a final question to think about. How would our lives be different if Earth didn't have that little tilt? What familiar year-long cycle would just completely disappear?